When given a function, how do you determine the domain of that function? So, first of all, we need to understand that most functions have a domain of all real numbers. Okay? And functions can look a lot of different ways. I could have an exponent on that function. The domain is still all real numbers. I could have larger exponents on that function. I could even change how I'm displaying those exponents. Domain is still all real numbers. I could have no variables in a function, just a number. We know that as a horizontal line. The domain is still all real numbers. So most of the time, the domain is going to be all real numbers. It's just a characteristic of functions. The two major exceptions. Okay, so these are our two exceptions. The first is when a function is a fraction with an x in its denominator. So that is a big exception. And the domain cannot be all real numbers simply because of that variable in the denominator. Something that we've learned over the course of math, over the course of this year, we've talked about this over and over again, is we've discussed that you can never divide by 0. As soon as we have an unknown in our variable, the opportunity to divide by 0 exists. So I need to take my denominator and make sure that it never equals 0. Well, obviously it's going to equal 0 if I let x equal 0. So my domain here is all real except 0. Similarly, h of x equals 5x minus 2 over 6x plus 3. Okay? I've got that component in my denominator that allows the denominator to equal 0. So I need to take my denominator and figure out when will it equal 0. So I'm going to solve this equation. Well, my denominator equals 0 when x is negative 1/2. So my domain has to be all real except negative 1/2. Okay? Now, I can have a function with a fraction where the domain is all real numbers. So why is this domain all real numbers? Well, simply because the denominator is a 2. That 2 can never be changed into a 0. So this function has no opportunity to be divided by 0. So my domain is all real numbers. Now, the second exception. The second exception, something that we've learned, is that when you're taking the square root of something, what's inside has to be non-negative. Otherwise, if you take the square root of something negative, it results in a non-real number. Okay? So, non-negative doesn't just mean positive. It means positive or 0. So something non-negative is something that is greater than or equal to 0. So if I have f of x equaling the square root of x plus 12, what's inside my radical needs to remain non-negative. So x plus 12 has to be non-negative. So x has to be greater than or equal to negative 12. That's my domain. Give me a number less than negative 12. For example, negative 15. If I go back to my function, negative 15 plus 12 is negative 3. And now I would have the square root of a negative 3, which would be non-real. Another example of that, square root of 2x minus 1. Okay? Again, what's inside the radical has to be non-negative. Some quick solving. My domain is that x is greater than or equal to 1/2. One last example. Square root of 3 minus x. So see if you can find the domain of that. Pause your video and see if you can find the domain. So this needs to be non-negative. So I've got to solve for x. I need to remember when I divide by a negative that my sign flips, so my domain is less than or equal to positive 3.